Welcome to Info 19 TV. Today we dive into the most abundant element in the universe, hydrogen. From the heart of stars to the air we breathe, hydrogen is everywhere. We'll explore hydrogen's journey from the Big Bang to its potential to power our future. Let's rewind the cosmic clock to the Big Bang, the moment when our universe burst into existence. Amidst the chaos and the swirling energies, hydrogen emerged as the dominant force, the simplest and most abundant element. Nearly 90% of the atoms in the observable universe are hydrogen. This tiny atom, consisting of just one proton and one electron, is everywhere. This vast reservoir of hydrogen fuels the stars, those celestial furnaces that light up the cosmos and create the light we see in the night sky. Stars are giant balls of hydrogen held together by their own gravity, constantly battling the forces trying to tear them apart. Deep within their cores, hydrogen atoms fuse together in a process known as nuclear fusion, where immense pressure and temperature force them to combine. This fusion releases an incredible amount of energy, which is why stars shine so brightly and can be seen from vast distances. Our Sun, an average star in the grand scheme of the universe, is powered by hydrogen fusion, a process that has been ongoing for billions of years. Every second, the Sun converts millions of tons of hydrogen into helium, releasing energy that sustains life on Earth, providing warmth and light. Fusion is a much cleaner process than fission, with helium as the primary byproduct, unlike the radioactive waste produced by fission. Hydrogen's role isn't limited to fueling stars, it's also key in forming galaxies, the massive structures that house billions of stars. After the Big Bang, gravity caused vast clouds of hydrogen to clump together, forming the first stars, which then began the process of creating heavier elements. These early stars eventually exploded as supernovae, scattering heavier elements across the cosmos and seeding new stars and planetary systems with the building blocks of life. Hydrogen is the fundamental building block of the universe, the simplest element that gave rise to the complexity we see today. It's the fuel that makes stars shine, and the element that made life on Earth possible, a testament to the power of this tiny atom in the grand tapestry of the cosmos. On Earth, hydrogen is essential, though we don't often see it in its pure form. Take water, for example. Each molecule consists of two hydrogen atoms bonded to one oxygen atom. Water covers about 71% of our planet's surface, making hydrogen key in Earth's climate and weather patterns. Hydrogen is also vital in organic molecules, the building blocks of life. Carbohydrates, proteins and fats all contain hydrogen. Hydrogen plays a key role in photosynthesis, the process by which plants convert sunlight into chemical energy. Plants use sunlight to split water molecules, releasing hydrogen to convert carbon dioxide into sugars. In our bodies, hydrogen is hard at work during respiration, combining oxygen with glucose to release energy and water. Hydrogen's influence isn't limited to natural occurrences. We've harnessed its properties for various industrial applications. It's used in the production of ammonia for fertilizers and in refining petroleum. Hydrogen is also a powerful rocket fuel, propelling spacecraft into orbit and beyond. From the oceans to the air we breathe, hydrogen shapes the world around us. Let's examine the unique properties that make hydrogen remarkable. Hydrogen is the smallest and lightest element on the periodic table. Its atom consists of just one proton and one electron, making it incredibly tiny. Because it's so light, hydrogen is highly reactive and readily forms bonds with other elements. At room temperature, hydrogen exists as a colorless, odorless, and tasteless gas. It's highly flammable, burning easily when exposed to a spark or flame. One of hydrogen's most remarkable properties is its ability to exist in multiple forms, known as isotopes. The most common isotope is protium, with one proton and no neutrons. Deuterium, with one proton and one neutron, and tritium, with one proton and two neutrons, have different properties useful for various applications. Despite its simple atomic structure, hydrogen is a complex and versatile element. Its unique properties make it essential for life, a powerful energy source, and a key player in countless industrial processes. Hydrogen's potential is vast, from nuclear reactors to fusion research. As we face climate change and dwindling fossil fuel reserves, the search for clean, sustainable energy sources is urgent. Hydrogen has emerged as a leading contender. It's incredibly abundant and when burned, releases energy and water as its only byproduct. One promising way to harness hydrogen's energy potential is through fuel cells. Fuel cells convert the chemical energy stored in hydrogen directly into electricity without combustion. The only byproducts are water vapor and heat, making it an incredibly clean energy source. Fuel cells can power cars, buses, homes and businesses. Imagine a world where cars emit nothing but water vapor and power plants generate electricity without polluting the air. This is the promise of a hydrogen-powered future. Let's delve into the numerous advantages that make hydrogen an incredibly attractive option for a sustainable future. Hydrogen is incredibly abundant, the most plentiful element in the universe, making up roughly 75% of all normal matter by mass. Unlike fossil fuels, which are concentrated in specific regions, hydrogen is available everywhere, making it a truly global energy source that can be harnessed by any country. Hydrogen is highly versatile, capable of being used in various ways to generate energy, from powering vehicles to fueling industrial processes. It can be burned directly as a fuel or used in fuel cells to produce electricity, offering multiple pathways for energy generation. This versatility makes it adaptable to a wide range of applications, from transportation to industrial manufacturing and even residential heating. Hydrogen is energy dense, packing more energy per unit of weight than any other known fuel, which means it can store and deliver a lot of energy in a small amount. A small amount of hydrogen can release a significant amount of energy, making it ideal for applications like transportation, where energy efficiency is crucial. Hydrogen is a clean energy carrier, producing only water as a byproduct when used in fuel cells or burned, which means it doesn't contribute to air pollution. This means no harmful greenhouse gas emissions or air pollution contributing to cleaner air and a healthier environment. Hydrogen can be produced from various sources, including renewable ones like water through electrolysis and biomass, making it a sustainable option. It can be stored and transported efficiently, making it possible to create a robust hydrogen infrastructure that supports widespread use. Hydrogen has the potential to decarbonize various sectors, from transportation to steelmaking, significantly reducing our carbon footprint. These advantages highlight hydrogen's potential to revolutionize our energy systems, paving the way for innovative and sustainable energy solutions. Hydrogen paves the way for a cleaner, more sustainable future, offering a promising path forward in our quest for renewable energy. While hydrogen's advantages are undeniable, several significant challenges need to be addressed to make it a viable energy source for the future. One main challenge is the cost of production, which remains high compared to other energy sources. Producing hydrogen from renewable sources such as wind or solar power is currently more expensive than producing it from fossil fuels like natural gas. However, as technology advances and economies of scale are achieved, the cost of green hydrogen is expected to decrease significantly, making it more competitive. Storage is another challenge. Hydrogen, being the lightest element, takes up a lot of space for its weight, requiring large storage facilities. Storing and transporting hydrogen safely requires specialized infrastructure, such as high-pressure tanks and pipelines, which can be expensive to build and maintain. The durability and cost of fuel cells, which convert hydrogen into electricity, are also hurdles. They are still relatively expensive to manufacture and have a limited lifespan. Public perception is also a factor. Some people associate hydrogen with flammability and danger, which can hinder its acceptance. However, when handled properly, hydrogen is no more dangerous than gasoline or natural gas, and safety measures are continually improving. Infrastructure development, such as building hydrogen fueling stations, is crucial for the widespread adoption of hydrogen as an energy source. A robust hydrogen infrastructure requires significant investment and coordination among various stakeholders, including governments, private companies, and research institutions. The efficiency of the hydrogen production, storage, and transportation process is constantly being improved through ongoing research and technological advancements. Producing, storing, and transporting hydrogen can result in energy losses, which need to be minimized to make the process more efficient. Improving efficiency is crucial to maximizing the sustainability and economic viability of hydrogen as an energy source. Competition from other clean energy technologies, such as wind, solar, and battery storage, is inevitable and poses a challenge to hydrogen's adoption. Hydrogen is not the only contender in the race for clean energy, but it offers unique advantages that make it a promising option. Despite these challenges, the potential benefits of a hydrogen-powered future are significant, including reduced greenhouse gas emissions and energy independence. With continued research, innovation, and investment, hydrogen can play a pivotal role in creating a sustainable and clean energy future for generations to come. From the birth of stars to a clean energy future, hydrogen's story is full of wonder and possibility. It's a testament to the power of scientific inquiry and the importance of understanding the building blocks of our universe. Hit like, subscribe, and tap the notification bell to stay updated on more informative content from Info 19 TV.